Okay, class, this is Algebra 2, Lesson 4.1, Quadratics. So Lesson 4.1, hopefully you're in the right place. And so here we go. All right, Chapter 1 in Quadratics, and my smartboard's acting a little funny right now. All right, let's see if things will work out for us. All right, we need to do an introduction, intro. All right, when you think about the word quadratic, the word in Latin is what helps us to understand here in math what we're dealing with. And the word in Latin means square. Square. And for us in math, what quadratic is any equation where the highest degree term is squared. Any equation where the highest degree term is, I'm going to finish in red here, squared. Any equation where the highest degree term is squared. All right, so that's the idea of quadratic. Here's the form. This is what they'll normally look like. I'm going to go A, and in red I'm going to go x squared plus B, back to red for x, plus C equals 0. All right, this is standard form for a quadratic equation. In this situation, the A is a constant or a coefficient, the B is a constant or a coefficient, and the C is a constant or a coefficient. All right, they're just simply numbers. Also, for it to be quadratic, A cannot equal 0. Because if A were 0, the x squared term would be gone, and it is this x squared term that makes it quadratic. All right, the highest degree term is squared. So if you were to look at an example of something that's quadratic, it would look something like this. 3n squared minus 2n plus 4 equals 0. Okay, how do we know this is quadratic? Because the highest degree term is squared. Okay, quadratics. The highest degree term is squared. Number two, 3 ways to solve quadratics. 3 ways to solve quadratics. This should be memorized. I will ask you this on quizzes. I will ask you this on tests. And the reason being is whenever you come across a quadratic equation, you have to think of these 3 ways to solve. You just have to. So you need to memorize this. This is important. You need to memorize it. Do something to make sure that you understand that this is important. You know, underline it, put an asterisk, do whatever you need to. But this is something you need to memorize. This is what you should be thinking every time you come across a quadratic equation. And look, you need to remember this for 2 years down the road when you're taking the SAT or the ACT, right? All right, so what are the 3 ways to solve quadratics? 1, take the square root of both sides. Take the square root. It'll be of both sides, and we'll add that later on, but that's the idea, taking square roots. The second way, basically, is with factoring. Factoring. And the third way is the quadratic equation, or some call it the quadratic formula. The quadratic equation or the quadratic formula. The quadratic equation or the quadratic formula. All right, so again, listen, memorize these. This you need to know. These are the thoughts you need to have when you come across a quadratic equation. You're going to come across when you're going to say, hey, how am I going to solve this? So again, for example, you come across this quadratic equation and you say to yourself, hey, how am I going to solve that? Okay, I'm going to either take the square root of both sides, or I'm going to factor it and solve it by factoring, or I'm going to use the quadratic formula. That's what you're going to do, okay? And so those need to be your thoughts. Number 3. This is a key concept. I'm going to do that in red. This is a key concept. This is really, some would call this the fundamental theorem of algebra. But it's simply this. the number of real and or complex number solutions is, I'm going to use red here again, less than or equal to the degree of the polynomial. The degree of the polynomial or equation. Let's say equation. The degree, we'll say polynomial, the degree of the polynomial. Okay, could be an equation. Either way, it doesn't really matter, and you'll see that. Okay, so let's apply this. So remember now, we are doing quadratic, right? We're doing quadratic, which we just said are what degree? Second degree, right? So therefore, according to this key concept, the fundamental theorem of algebra, there are two solutions. And you need to expect that. Now, the reason I say less than or equal to is sometimes the two solutions are the exact same value, in which case you would only consider it one. You'll see that in a little bit. But normally you see a second degree equation, second degree polynomial, you're thinking two solutions, two solutions, two solutions, two solutions. So let's take a look at this. So little b, why two solutions? Why two solutions? And by the way, if we had a third degree polynomial, you'd have up to three solutions. Fourth degree up to four, fifth degree up to five, eighth degree up to 8 solutions. We're dealing with two solutions right now because we're dealing with quadratics, second degree. Okay, I think I can get you to understand that with a simplistic quadratic equation. X squared plus 2 equals 18. All right, very simplistic quadratic equation. X squared plus 2 equals 18. You say, okay, this is quadratic because the variable is squared. The highest degree term is squared. Hey, this is quadratic. And according to the fundamental theorem of algebra, I should have up to 2 solutions. Okay, so let's take a look at this x squared and just think about the simplistic nature of this equation. What must the value of x squared be to make this equation true? What must the value of the x squared be to make the left side equal the right side? Right? I mean, that's what we're looking at. What must the value of the x squared be? Okay, so I hope you agree that this x squared must be 16, right? Because 16 plus 2 equals 18 has to be. Okay, but that's not the value of the variable, right? The x squared must be 16. So what do we then conclude? X can equal what number? Have you thought of 4, right? Obviously. Does 4 work? Yes. 4 squared is 16. 16 plus 2 is 18. 18 equals 18. What else could x be? Or x could equal what other value? And I hope you thought of negative 4. Because negative 4 times negative 4 is positive 16. And 16 plus 2 is 18, and 18 equals 18. See, we have two solutions. Now, I used a very simplistic quadratic equation to help you to understand this. Even when they're complex, the reality is there are two solutions. And that's what we have to keep in mind. You've got to keep in mind the fact that if you're solving a quadratic, there are going to be two solutions, up to two solutions, almost always two solutions, and you have to expect two solutions. That's really important. Okay, all of that is by way of introduction. So 4.1, solving by factoring. Of those 3 kinds, we're going to do the first one. 3 ways of solving. We're going to do the first today, solving by factoring. Now, I don't mean to scare anybody that's not great at factoring. We did practice factoring in the beginning of the year. And here's the reality. One of the main ways of solving quadratics is solving by factoring. So you got to know how to factor so that you can solve by factoring. I will tell you this, some of the factoring we'll be doing in solving these is some of the easier factoring, okay? So if you weren't the greatest at factoring, it is some of the easier aspects of factoring. Okay, before we get there, we have to think about this property. It's the basis and foundation of solving by factoring. It's called the zero product property. Zero product property. We deal with this property way down in pre-algebra. Zero product property. And it simply is this. When quantities are multiplied and the product is zero, so let's just make it simple. When the product is, and I'll go red, 0, go back to blue, at least one of the values, at least one of the, let's change that. Let's say at least one of the factors. That's better. That's what I like. And I'm going to write that in red. At least one of the factors must be 0. It's the only way you're going to get 0. Okay? Zero product property. If when the product is 0, at least one of the factors must be 0. Okay, again, we took time and developed all this way back in pre-algebra and algebra 1. So I'm going to go a little bit more quickly, but I am going to try to develop it for you. So let's take a look at something. Let's suppose we have something very simplistic like this. 7 times x equals 0. Okay, we have two things multiplied, a 7 and an x. You know what? There's only one way you are going to get this thing to equal 0. And you know what? The reality is this. X must equal 0. It has to. There's no other way to get to 0. All right, nothing else will get you to 0. Nothing. X has to be 0. Now, what if they do something like this to you? What if they have x times y equals 0? Now we have a couple possibilities. And there's really 3 possibilities. Some call this trichotomy. And it's either x equals 0 or y equals 0, or what's the third one? Both equals 0, right? Those are the possibilities. Has to be. There's no other way you're going to get to 0. Okay? You got two things multiplied. There's no other way. And look, this can be 40 or 50 or a million things multiplied in a row. One of them at least has to be 0. That's the zero product property. All right, so let's look at a few other aspects of this. And let me give you a little progression. Let's suppose we had something like this. Let's suppose we had 5 times the quantity x plus 1 equals 0. Now there's only one variable. In order for this to be true, what must x equal? What must x equal? Well, here's the reality. This quantity of x plus 1 must equal 0. It has to. It's the only way you're going to get to end up with 0. You have to do 5 times 0. So look, you can do this in your head then, right? X therefore must be -1, right? Therefore, 3 dots in a triangle is therefore x must equal -1. Because what happens when -1 is in for the x? This whole quantity becomes 0. 5 times 0 is 0. All right? D. All right, so how about something like this? Pretty simplistic. The quantity y minus 6 times 7 equals 0. What must y equal? And I hope you said 6, right? Put in that 6 for the y. What does that give you for the quantity? 0. 0 times 7 is 0. And therefore the x must have been a 6. Okay. Now let's see what you can do with this one. All right, let's suppose we had something like this. -7 times the quantity 3x plus 4 equals 0. This one's not so clear, is it? It's not so easy for you to just look in here and say, what makes this quantity 0? But listen, don't miss this. Don't miss this. Don't miss this. This is the key. All you have to do is take the quantity that has to be 0, set it equal to 0, and solve the little equation. Okay? Let's move the 4 to the other side by adding a negative 4 to both sides. Here, I better not skip steps. I better show it to you, just so you don't get confused, right? And now how would we move the 3? We're going to divide both sides by 3. And what do we end up with? X equals negative 4/3. When the x is a negative 4/3, this quantity becomes 0, and negative 7 times 0 is 0. So what did we just do? This one was not easy to do in your head, right? It wasn't easy. It's not simplistic one to look at. Now, once you understand what's going on, you can do it in your head. But it's not obvious to most students. What did we do to figure it out then? We set it equal to 0, and we solved the little equation. And we figured out that x has to be negative 4/3. You don't believe me? Stick it in there. A negative 4/3 is going to make the front term end up being a negative 4. Negative 4 plus 4 is 0, and you get 0. Okay? So don't miss this aspect of set the quantity equal to 0 and solve for the variable. Set the quantity equal to 0 and solve. This is a key concept, and students forget it. I don't know why, because I show it to them every year, but they forget it, and therefore then they don't get the problem correct. Okay, so I'm giving you a progression. I think this is E, this is F. F. Okay. What about this? The quantity x minus 3, use your black here for the second quantity, times the quantity x plus 5 equals 0. Okay, look at this now. This is actually quadratic. Because you know what? For this first quantity, what if the x were a 3? Wouldn't that make the first quantity 0? Now look, when we say x is 3, we mean it in both spots. Okay? So what do I mean? This is what I mean. 3 minus 3 and 3 plus 5 equals 0. Does it? Yes. 0 times 8 is indeed 0. See? However, what would make the second quantity 0? And I hope you say when x equals negative 5. Again, if you can't do that in your head, you're going off to the side and you're making your little equation and you're solving it for the variable, right? So again, what are we saying? We're saying if the x's were a 5, then you get 0, right? I'm sorry, negative 5. You would get a 0, because what do you get? Negative 8 times 0, and sure enough, that's 0. Now, look at this. Please, please, please. If you were in class, I'd be showing you this with my hand on the board, so you got to be careful here. But look, notice the first time we're saying if both of the x's are 3. Do you follow? And the second time we're saying if both of the x's are negative 5. We're not saying the first x is a 3 and the second x is a negative 5. No, no, no. We're saying if both x's are 3, it comes out to 0. And if both x's are negative 5, it comes out to 0. There are two solutions. So really, these were the solutions to this problem. Okay? They were the solution to this problem. Let's do one more. G. Okay, so how about something like this? This is off the wall. X times the quantity, y minus 2 times the quantity, 3z minus 4 equals 0. Okay, in this one, what if this x were a 0? Would that make everything 0 no matter what everything else is? I hope you agree it would. 0 times This is 0, and 0 times that is 0. Therefore, we get 0. Okay, it works. All right? What about this second quantity? The y would have to be a what to make this 0? And I hope you agree at 2. How would this work? Anything times 0 is 0, and 0 times anything is 0. And there we have, again, 0. And what about the third situation here? Okay, so again, some of you don't do these well in your head, so you make the little equation. Move the negative 4 to the other side, move the 3, and we say z equals 4/3. When z is 4/3, that will make that last one 0. Anything times something else is something, but anything times 0 is 0, and again we get 0. Okay, that's how it's working. So what are our solutions here? We have 3 of them. 1, 2, and 3 solutions. Okay? That's the idea. That's the way it goes. So number 2. What does it mean to solve by factoring? So number 2, solving by factoring. What do? Number 1, set the equation equal to 0. Set the equation equal to 0. If it doesn't already equal 0, move things around to make it equal 0. I'll show you that in a little bit. Step number 2, once it's equal to 0, factor. Step number 3, set each factor equal to 0 and solve. Set each factor equal to 0 and solve. And again, you'll be able to do some of those in your head. All right. So before we get into these, let me just review. Okay, solving by factoring, right? Quadratics. Latin means squared. How do we know it's quadratic? Because there's a square term, right? There's a square term. What are the 3 ways of solving? Taking the square root of both sides, factoring, that's the one we're doing right now, right? And the quadratic equation. Key concept. The number of solutions equals the degree. If it's a second degree, you're going to have 2 solutions. How do you solve by factoring? We're going to use a zero product property. Things multiplied together, if they equal 0, then one of them has to be a 0. We went through the progression, and now that leaves us right here. So let's do some examples. Number 3, examples. Examples. All right, A. Here's our first one. X squared minus 3x minus 4 equals 0. All right, first thing. Set the equation equal to 0. Check. It's already done, right? Second thing. Factor. Okay. This is what we're factoring, this side, right? We're factoring the trinomial. Do you remember how to factor a trinomial? 2 parentheses, right? By the way, this thing still equals 0. What times what equals an x squared goes in the front. What times what equals a negative 4 goes in the back. But remember, there are different possibilities. What are we after when we multiply the outers and add to it the multiplication of the inners? That's got to equal negative 3x. So with a negative 4, I've got some choices. So again, I'm looking, what will give me a negative 3 in the middle? So I'm thinking to myself, if I put a negative 4 here, that's a negative 4x. The positive 1 would go here, because positive 1 times negative 4 is this negative 4, right? That's got to work. That's got to be the case. All right, and so I'm going to get on the outers, right here, x times negative 4 is a negative 4x. On the inners, 1 times x is a positive 1x. Doesn't that equal the negative 3x? It does. Right? It does. So again, let me get all this out of the way, because this is all just the thinking for the factoring. We were after the factoring, right? That's what we wanted. Okay, so look where we are. This thing is just like that example right there, right? Doesn't it look just like f? Look at f. Parentheses times parentheses equals 0, right? So look where we're at. X plus 1 times an x minus 4 equals 0. So again, a lot of you at this point, you can do them in your head. But again, let me just show you what you would do. Take the first parentheses and set it equal to 0. And again, obviously then x is a negative 1, right? Negative 1 in both spots would make the first parentheses a 0 times the second number, giving us 0. For the second parentheses, x minus 4 equals 0, then the x must be a 4, right? Second value, second answer. And again, if you put 4 in both spots, remember, this is what we're saying. If the x's were a 4, I'd end up with 5 times 0, and that's 0, right? And the other way I'm saying, if the x's were a negative 1, I end up with 0 times a negative 5, and that's 0. Okay? Do you follow? So there's our two solutions, right? And that's what we expected. It was quadratic. We were expecting two solutions. We got two solutions. Let's do another one. B. All right, how about this? X squared minus 6x equals negative 5. X squared minus 6x equals negative 5. Hey, what's the first thing we want to do? And hopefully you'll look back there and say set it equal to 0. Okay, we got to add a positive 5 to both sides, right? Again, Algebra 2, normally I wouldn't show that step. I'm just showing it for your sake so you're following along what we're doing. So x squared minus 6x plus 5 equals 0. Okay, now it's set equal to 0. Now let's factor. Again, the fronts have to multiply to x squared. That's easy, x and x. The backs have to multiply to a positive 5. But remember, the outer and the inner must give us a negative 6. There's only one possibility on this. That's a negative 1 and a negative 5. Again, I'll show you the check. Negative 5x, negative x is that negative 6x, right? Again, let me get my check out of the way so we can finish the quadratic. So again, how would you finish? You're going to set each parentheses equal to 0. X minus 1 equals 0, so x equals 1. X minus 5 equals 0, so x equals 5. Now again, I did the little equation in my head. If you can't do it in your head, then write it out, right? And the more complicated ones, some of you won't be able to do in your head. There's the two solutions. And we were expecting 2 because it was quadratic, right? We were expecting 2 because it was quadratic. Let's do another one. C. What would you do with this? What would you do with this? What if we had something like this? 6 equals negative 3x squared. I'm sorry, negative 6 equals negative 3x squared plus 7x. Okay, I have two choices. I can move the negative 6 from the left to the right and set it equal to 0 with the 0 in the front. And I could do that, and it would look like this, right? And that would be a 0. Here's the problem. We don't factor very well with a negative lead term. We don't. So to be honest with you, I wouldn't do that methodology. I mean, you can. It'll work. You just got to know what you're doing. But you know what? Because this squared term is a negative, I want to move it to the other side. I want to add a positive 3x squared to both sides. So that's going to get the 3x squared on the left and positive. But look, we got to move this 7x as well, right? How do you move it? Same way, add its opposite, right? So we're also going to add a negative 7x to both sides. So that moves that, and that's where we're at right now, right? 3x squared minus 7x minus 6 equals 0. Look, at this point in our algebra, this is what should be happening, and this is what we should be thinking. If I want this negative 3x squared on the other side, it becomes a positive 3x squared, right? And if I want this positive 7x squared on the other side, it becomes a negative 7, a positive 7x, excuse me, on the other side, it becomes a negative 7x. That's all. Don't make these hard. Okay, now we're ready to factor. All right, I'm going to give you a minute. You might want to pause the video right now and see if you can factor that. Okay? Go ahead and pause. See if you can factor it. See if you can finish it. And then turn the video back on and see if you got it right. All right? Pause it right now, please. Okay, so if you're back from pausing, and I hope you did pause and do it, your choices now are 3x and x, right? And remember from factoring, this 3 in the front's that's going to make a difference. Okay, I've got a negative 6 in the back. So I need to multiply to a negative 6, but remember, the whole time I'm thinking about this negative 7 in the middle. That's what I've got to get to. So I can use 6 and 1 or 3 and 2. Ooh, 3 and 2. If this is a 3, that's going to be a 9x. But if it was a negative 3, it'd be a negative 9x, leaving the positive 2 there for a positive 2x. And you know what? That's what I need, because those two together give me that negative 7x, don't they? They do. Listen, you got to get your factoring right if you're going to get these correct. So those are the two quantities. How do you finish? Set each one equal to 0. Move the 2. Becomes a negative 2 on the other side. Divide by the 3. X equals negative 2/3. That's one solution. This one you can do in your head, right? X equals 3, and there's the second solution. All right, did you get it right? X equals negative 2/3, X equals 3. All right, I hope so. Let me show you one more. Let's do one more here. For some reason, this one gives students trouble. I don't know why. How about something like this? 12x squared minus 4x equals 0. Here's what the problem is. What's the first law of factoring? Now, I haven't been reminding you of this because I'm trying to get you to learn the other concept. But now we got to start thinking about what we're doing when we're factoring. What's the first law of factoring? What did I teach you the first law of factoring was? Right? What did I teach you? I said right, factor out common factors first. Don't forget that. Factor out common factors first. We have a common factor in the 12 and the 4. We have a common factor in the x's. So hopefully you thought I can factor out a 4x as the common factor out of this. A 4x out of the front leaves you a 3x. A 4x out of the back leaves you a negative 1, right? Remember how many times I said don't forget the 1? And again, if you're correct, if you did it correctly, you should be able to multiply it back out and get right back where you were, right? So again, what would happen if you multiply that? 4x times 3x, 12x squared. 4x times negative 1, negative 4x, right? Okay, I'm right. That was correct factoring. Now look, we're ready. We already have two quantities. If you want to, you can set the 4x equal to 0. And that means x must have been 0, right? Set the 3x minus 1 equal to 0. Right? Negative 1's positive on the other side. Divide by the 3, and x equals 1/3. So x equals 0. X equals 1/3. All right, that's the beginning of quadratics. Come into class tomorrow, and we'll work some problems in class. All right, have a great day.